Alright, good afternoon everybody. Ready to talk about the alpha and beta decay FET simulations. This video is going to be just about the alpha decay. So here's what we're going to do. We're going to look at this. So we're going to follow these instructions. We're going to go to this simulation. I'm going to click on single atom. I'm going to pick the polonium-211 nucleus and run the simulation 4 times. So here is this. I'm going to go to single atom, polonium-211. Run the simulation. Okay, so I did it once. It lasted, well, not quite a second, 750 milliseconds. That one lasted 30 milliseconds. This one, it's going, obviously this isn't real time because now we've just about getting to 1 second worth of real time. So that one lasted 1.3 seconds. Slowed down so we can kind of see what's going on with this nucleus. Obviously this is an unstable nucleus, as you can see. Alright, that one lasted 1.2 seconds. So I've got 4 things there to think about. I'm going to switch back here. Write the atom you are beginning with in atomic symbol notation. So to kind of illustrate how that works, here is the superscript and the subscript. So I'm going to start with the superscript to write the mass number, which if I look back at this and I start with it, it is 211. Okay, so 211. Then I'm going to come up and I'm going to click the subscript, and I'm going to have to look up. It's I know it was polonium, so I'm going to look over at a periodic table and find polonium. Polonium is element number 84. So that means it has 84 protons. So when I come back here, I can write 84 like that. And then I can click off of that and PO. So this is how we can write atomic symbol notation in Word pretty easily. After the alpha decay, what atom are you left with? I'm going to leave you to figure that out. What element has the same protons as the particle emitted from alpha decay? Write it in atomic symbol notation. So here's what I will encourage you to look at. We know that it lets off 1 particle, right? We start with polonium-211 and we end with lead-207. If I come back to the periodic table, polonium has 84 protons, lead has 82 protons. So I want you to think about how many protons does the particle coming out of there have, and what element would that be? And then so you're going to write the nuclear reaction. You can do it just the same way we did above, this, and this is going to be what you start with, the polonium, and then it's going to become 2 things, the lead and the other particle that comes off, plus gamma radiation. I just want to be clear, gamma radiation comes out of pretty much every nuclear reaction. So we always want to be thinking about that. I want you to describe what happens. I want you to draw alpha decay. Again, you can use the draw tab up here. You can do it like that. You can do it with shapes if you want to use shapes. I think the draw is probably the simplest and easiest to do. So that's what I would do. And then think about the energy of the atom. Think about why are protons and neutrons vibrating? What flew off during decay? Why do you think this occurred? And do you think something that is stable or unstable has more energy, and why? All right. Those are all of the answers, things I want you to answer for part 1. So I'm going to stop right there, and we'll come back with part 2 in just a second.